Alright, so we're going to look at solving problems with linear velocity. These are the examples that I'm going to work. Uh, Example 1, 2, 3, 4, and 5. You can take a look at them. Each problem will have its own video. So this will be video example 1, 2, 3, 4, and 5. And there's 5. Check it out. It has a little twist to it there. So, check them out. So, but before we get into looking at the problems, let's look and see the linear velocity. It says if P is a point on a circle of radius r and P moves a distance s on the circumference of the circle in an amount of time t, then the linear velocity v of P is given by the formula V equals S over T, where S is theta times R and theta is in radians. So basically, S, you should recognize this formula. This is just the formula for arc length. Okay, and it's important that you make sure that theta is in radians. Okay, and also to find the linear velocity, we can write the linear velocity v is equal to r times omega, and omega is the angular velocity. So if you know the angular velocity and the radius, just plug it in there and that'll give you the linear velocity also. Alright, so let's take a look at an example. Alright, so let's take a look at example 1, example on linear velocity. It says a record is turning at 45 revolutions per minute. If the distance from the center of the record to a point on the edge of the record is 3 inches, find the linear velocity of the point in feet per minute. Alright, so first let's just go ahead and write down the formula. So we got the linear velocity is s over t, and we know that s is theta times r, where theta is in radians. Alright, so let's look at a couple of things. They want us to find the linear velocity in feet per minute. So the time that they give us is minutes, revolutions per minute. Okay, so we're good on the time. But notice the radius that they give us is in inches, and we want our final answer in feet. So two ways you could do it is you could convert the inches to feet and then work the problem, and that's not that difficult to do here. But what I would recommend doing, because sometimes the conversions might get a little more complicated than just going from inches to feet. So what I would do is I would just work everything in the units that are given and get the answer in those units, and then convert that to whatever units they're asking. So for what we're going to do is we're going to find inches per minute, and then once we get that answer, we'll convert it to feet per minute. All right, so we need to find S. So, well, we can see that R, our radius, that's the 3 inches. And then theta, well, let's see. What's the angle that it makes? Well, it's 45 revolutions per minute. So in 1 minute it goes around 45 times. And when it goes around one time, that's 360 degrees, but we need to be in radians. So instead of 360, that would be 2 pi. And then we go around again, that would be 4 pi, 6 pi, 8 pi, 10 pi, and so on. So what would be the angle? Well, it's 2 pi times the number of times that it's going around, which is 45. So here we have theta is equal to 45, that's the number of times it goes around, times 2 pi. That's the angle it makes each time it goes around. So that's going to be 90 pi. So there's theta. All right. So now let's just go ahead and get S. So we have S, okay, because we need S for our formula. So S is theta times R, so 90 pi times R, which that's 270 pi. So now let's plug this in. So I get my linear velocity is S, which is 270 pi. Okay. All right, and remember, all S is the arc length. Okay. All right. Now, what's time t? Well, S is 270 pi. Okay, that's 270 pi. Well, how long did it take for that point to go 270 pi? Well, it's revolutions per minute, so it took it 1 minute. So t is 1. And so the linear velocity is 270 pi, and that is inches per minute. Okay? All right, but that's not how we want our answer. We want our answer in feet per minute. So the linear velocity, which is 270 pi, and that's inches per minute, and that's 1 minute. All right, so we need feet up here. Okay, now the minute's good. We can, the minute, we need to keep that, but we need this in feet. All right, so we need feet up here. All right, and we need to cancel out inches. Well, we know in 1 foot there's what? 12 inches. Okay. All right, so now we have the inches cancel out, and you can see we're left with feet per minute. And so let's see, I'm going to just do the 270 divided by 12, and that is going to give me 22.5 pi, and that is going to be feet per minute. Okay. Now, if you wanted to, you could go ahead and multiply the 270 and the pi and divide that by 12. So let's see what that would give us. So 270 times pi, and then divide that by 12. So if we put that in our calculator, we would get 70 point, and I'll round to 1 decimal place, feet per minute. Okay. All right, so I hope the video helped. Give me a like, share, and subscribe, and check out my other videos, and thanks for watching.